Hey everybody, in this lesson, we're going to be talking about factoring special fourth power trinomials. So you're kind of not really going to learn anything new, but it is going to be kind of like the last lesson where you're going to be able to factor something that you wouldn't be able to factor out before just by applying like a couple of simple steps. So again, the title for today is factoring special fourth power trinomials. So the reason why they're special is because they're actually factorable. And they're actually factorable in a way that we already know how to factor. So let's start out with some definitions. So first of all, fourth power polynomial. In this case, fourth power polynomial is basically any polynomial with a degree of 4 as the maximum power. And when we're factoring fourth power polynomials or trinomials, basically it is the exact same thing as what we did when we factored quadratics. So that's why I'm saying you're not going to be learning anything new. You're going to be getting the product of two binomials, but in this case, it's going to be two quadratic binomials. And then we'll go into more detail once we do some examples. So like I mentioned, there's going to be not that many steps because the other steps you should already know how to do. You should be doing the assignments in order. Like for example, don't start at the end because then you will be lost. So you want to go in order from the first couple of lessons to the last few lessons by date. So the steps that I have here, I only have 4. First step is basically use another variable to substitute for the variable squared. For example, I like to use u substitution. The next time you will hear the term u substitution will be in calculus, but let u equals something. So in this case, I have let u equals x squared. 2, continue factoring the trinomial squared by using methods you already know. So again, you already know how to do this. We're just going to make it look differently. And then number 3, do not forget to substitute back to the original variable because the original variable most likely was not u. So if we switch from x squared to u, then we have to make sure to switch back from u to x squared. Step 4 is basically if you can factor it further, you should. If you can't factor it anymore, then big deal, you're done. So don't let that bother you. Sometimes you can't factor stuff, and if you can't factor it, oh well, you're done. Okay, let's start with this example. You already should know how to do this. So this is basically review because you should already know how to do this. We have the A term in this case is equal to 9, the B term in this case is equal to 15, and the C term in this case is equal to positive 4. If you want to factor this out, most likely the steps that you would take is to draw a big X, multiply the A times the C, right? The first term multiplied by the last term. So that would be this one multiplied by this one, which will give you a total of 36. I'm going to put that on top. On the bottom, I'm going to put the middle term, which happens to be the letter B. And in this case, the middle term would be the number 15. So now from the other steps, you want two numbers that multiply to 36 but add to 15. That shouldn't be that hard by now. 12 times 3 would give you 36. 12 plus 3 would give you 15. And then you would normally do this. You would set up the AX. Don't forget the A. So it's 9x times something, and then 9x times something. The two terms that go here would be the 12, positive 12, and positive 3. And then we want to figure out what can we divide both of them by. In this case, the left term, I can actually divide them both by 3. And then the right term, I could also divide them both by 3, which would give me my final factors overall, which in this case would be 3x plus 4, right? Because 12 divided by 3 is 4. And then to the right side, I would get 3x plus 1. Again, you could always go back and check your work, make sure that everything multiplies out to the original problem. If it does multiply out to the original problem, then you know you did it right. Now, you should know this already. If you don't know this, you should go back to another lesson and review how to factor trinomial squared or factor quadratic expressions, basically, because this is what this is. In today's lesson, we're actually going to be doing something similar. The only difference is that instead of having to the power of 2, we're going to be having something to the power of 4, right? But if you notice, I gave you the exact same problem. So check this out. It's like 9x squared plus 15x plus 4. In this case, instead of a power of 2, I give you a power of 4. 9x to the power of 4 plus 15x squared plus 4. So if I want to change to something that's a power of 4 into something that's a power of 2, I could really easily do that by just saying, okay, this is the only step that I give you. So I'm just going to put the step on the left-hand side. I'm going to say let u, just a random variable that I chose. You could use any other variable that you want, w, z, whatever. Let u equals x squared. So if I let the variable u equals x squared, then this is going to be 9 times u squared, right, plus 15 times u plus 4. So the only thing that changed is this right here. I replaced u with x squared. And the reason why this works out is because x squared, u squared, right? So I'll write it on the side. U squared would be just x squared times x squared, which would give you x to the power of 4. So this actually works out identically. So now this became the problem that we just solved, right? So I'm not going to bother you with the nonsense about doing the problem all over again. We already know what the answer is, right? Well, we did the x, we put 36 on top, 15 on the bottom, found the two numbers that multiply to the top and not to the bottom, and we got the final factors, which is 3x plus 4 and 3x plus 1. In this case, instead of the x, though, I'm going to be replacing that with u. So when I factor this out with the x, I would get 3u, what was it again? 3u plus 4 and then 3u plus 1. So you would factor it out like you normally would, and then you would write the factors out. So this is the final answer. The only problem is my original problem did not have any u's, so I would highly recommend for you to change those u's back to x squares because those are actually what the problem would say. So the actual final answer for this would be 3x squared plus 4 multiplied by 3x squared plus 1. And this is your factored form. Now, if you can factor any of these even further, you should. If you can't factor them anymore, then you're done. In this case, I'm done because this is not something that I can factor out anymore. It is not a trinomial squared. It is not a difference of squares. So I'm pretty much done. I can't break this up any further. So that is it for example 1. Let's do a couple more examples and you will see exactly what I mean. So we want to factor this following expression, right? So x to the power of 4 minus 6x squared minus 16. I'm going to start off with saying, okay, I don't want to be dealing with powers of 4s. I'm going to be saying let u equals x squared. So like I said in the last problem, so if I replace that x to the power of 4 by using this substitution of u equals x squared, I'm going to be left with a different equation or different trinomial, which in this case is u squared minus 6u minus 16, right? And then basically all I did was substitution. So basically u times u would be u to the power of 4, and then u is just x squared, so I basically replace that u with x squared. The rest you know how to do. So let's say I wanted to solve this, right? So I want to factor this out. I would draw a big X, multiply a times c, put it on the top. So in this case, I would put negative 16 on top because that would be 1 times negative 16. B, I would put it on the bottom, which is negative 6. I want to figure out, okay, what are two numbers that multiply to the top but add to the bottom? So in this case, the two numbers that give me the top and then add to the bottom would be a times 2, right? A times 2 would give you 16. And then one of these has to be a negative because I want negative 16. If you notice, this is going to be a negative 16. You want it to, negative 6. You want it to add up to negative 6. So this has to be a negative 8 because negative 8 plus 2 would give you negative 6 when we add it up. But if you multiply, you get negative 16. That's it. So now you want to write your factors. If you remember from the steps, you write ax, or in this case, au. We don't have anything except for the 1 in front, so I'm going to write just u and u because there's no other term in front because the original one had a 1. I'm going to be writing the factors as negative 8 and positive 2 because those are the two factors that I got. And then finally, since my original problem was actually in terms of x, I don't want to leave it in terms of u because u is something that I did to the problem. That's not what the original problem actually said. So I'm actually going to go back and replace those u's with x squares because that's what the original problem stated. So my final factors would be x squared minus 8 times x squared plus 2. Okay, now notice that I'm circling it now as my final answer. And the reason why I'm doing that is because I know that I cannot break these up any further. So this is not a difference of squares because 8 doesn't have a perfect square root. This is a sum of two terms, which I can't even factor that out. So I'm pretty much done. Okay, so if at any point you want to check your answer, you could always multiply this with the box. It should give you back your original problem. Okay, you should always check your answer if you're not sure. Okay, example number 3. Another special fourth power. Let's say we want to factor this out. I'm going to start the same way. I'm going to say let u equals x squared. So when I replace u with x squared, basically what this is going to give me is u squared minus 81, right? So when I have u squared minus 81, notice that this is actually a perfect square. So I can actually use the difference of squares property. If you forgot the difference of squares property, it was in another lesson. It just says a squared minus b squared. So when two terms are subtracted and they're both squared, perfect squares, you can skip right to the answer as a minus b multiplied by a plus b. So that is what we're going to be using in this example, right? So this is a difference of squares formula. So right here, I know that this is actually a perfect square. U times u would give you u squared, and then 9 times 9 would give you 81, right? So I can skip right to the answer as this is going to be u minus 9 multiplied by u plus 9 by using that difference of squares formula. Now, once again, my original problem did not have a u. My original problem actually had an x. So I'm going to go ahead and switch it back to the original problem, which was x squared. U was x squared, right? So swap it right back. So x squared minus 9 and x squared plus 9 would be my two factors. Now, stop and wait for a minute. I am not going to go ahead and circle the answer yet because I know that I can factor it a little bit more. I could actually use the difference of squares property one more time. If you notice right here where I'm going to underline the purple term, x squared minus 9 is actually factorable one more time. I could actually take the square root of this and get a perfect square, and I can take the square root of that and get a perfect square root. So I'm going to go ahead and do that. When I factor this out, the square root of x squared is just x, and the square root of 9 is 3. So basically my two factors, again, I'm using the same formula that I have up here. I'm breaking it up even more. That'll give me x minus 3 multiplied by x plus 3 when I break that up. This came from the purple stuff that I underlined. And then can I break this up more? The answer is no, because this is not a difference of squares. This actually has a plus sign, which means that we can't really use any formula to break that up. So my final answer would be x minus 3 multiplied by x plus 3, and then multiplied again by x plus 9. So this will be my final three factors. And then I can go ahead and actually circle this because it is not factorable anymore. I went as far as I could go. Okay, so you want to basically break it up as much as possible. If you can still break it up, keep going. All right, so that was example number 3. I don't even know how many I have for you. I think like 4, maybe 5. This example 4, it says factor the following expression. So I want to figure out what is this when I factor it out. Same thing, use substitution. So I'm going to say let u equals x squared. I like using u because it's, simple. It's not a variable. It's very often used. So I'm going to be replacing this. I'm going to write this as 2u squared plus 7u plus 3. Then I want to factor this out. So same thing, I want to do the big X. I want to figure out what goes on top, what goes on the bottom. A multiplied by C, which is the first, multiplied times the last, which in this case gives me a 6 on top. On the bottom, I have the middle term. In this case, the middle term is positive 7. So I'm going to put the 7 on the bottom. I want two numbers that multiply to the top number, but add to the bottom number. That would be 6 and 1. So some of you guys are really, really pretty good at this by now. So you can skip to the final two factors. Again, don't forget that ax goes first. So in this case, it will be 2u and then 2u. I want to put the factors out here. So this is going to be a positive 6 for the first factor. This is going to be a positive 1 for the second factor. Now, I would be done. But then again, remember, the original problem had x's, not u. So we got to go back and switch it real quick. So this is going to have to go back to an x to the power of 2. So big deal. Just switch it real quick. 2x squared plus 6, and this is going to switch back to x squared. My bad. I just realized that there was a mistake on this. This actually is not 2x squared plus 6 and 2x squared plus 1. I forgot to divide this by 2 here and there, so the final answer should actually be, what is it? When I divide this by 2 and I divide this by 2, I will get x squared plus 3 multiplied by 2x squared minus 1. So the final answer, sorry if I confused anybody, should be x squared plus 3 multiplied by 2x squared plus 1. That should be the final one. All right, that is it. Next problem. One last one. So same idea. We have to factor the following expression: x to the power of 4 minus 10x squared minus 9. Again, let's use u substitution. So let u equals x squared. We're going to replace all the x squares with a u, which in this case, I have two of them. So same idea. We're going to have u to the power of 2 minus 10u and then minus 9. So just replace any x squares with a u, and then you can do the rest of the problem like you know how to do it already. So let's make a big X. First times the last goes on top, that would be a -9. The middle one goes on the bottom, which is a -10. We want two numbers and multiply to the top one, but add to the bottom one. So 9 times 1 would be -9, and then it should add to -10. Did I mess up writing this problem? Oh, I did mess up writing this problem. I'm sorry about that. So the original problem, I'm looking down at my notebook and I actually see that I wrote the problem wrong. I'm like, this is not factorable. So we can't do this. The original problem is actually supposed to have a plus sign for the 9. So it's a really quick fix. Nothing crazy since I haven't really done anything thus far. That's not crazy. So when I multiply the first term times the last term, it should actually be a positive 9 on top. And then I want two numbers and multiply to the top number, but add to the bottom number. So that would be a -9 and -1. -9 times -1 will give you a positive 9, and then -9 minus 1 will give you -10. Sorry about that. My example, I typed it in wrong. But anyways, so that's not the point. The point is u substitution. So when we factor this out, we're going to have the two factors, right? So we're going to write u here, or some of you guys want to write 1u and 1u. The answers for the x actually go here on the sides. In this case, it would be -9, and in this case, it would be -1. So we basically want to substitute again. So now that we know what the factors are, we're basically done. But I'm done in quotes, right? Because we want to check to make sure if it's factorable a little more. So I'm going to replace the u back to x squared because my original problem had x squares. So let's replace that. That will replace this with x squared minus 9. That would replace this with x squared minus 1. And then I would be done if I can't factor this anymore. But if you actually go back and check the problem, this actually is factorable a little more. So if I check this is actually a difference of perfect squares. And if I check the other one, this is actually also a difference of perfect squares. If I take the square root of this, both of them, this will be x and this will be 3. Like a nice even number. If I take the square root of both of these, this will be x and this will be 1, which again gives me a perfect square. So since I can break it up even more, I should, because I want to factor this completely. So my final two factors would be x minus 3 multiplied by x plus 3. I use the difference of squares property. And then if I do it again here, this will be x minus 1 multiplied by x plus 1. Again, I use the difference of squares property. So that crazy polynomial that we started off with just became these four factors. So basically this times that times that times that, if I multiply them all together, you might need like 3 boxes. You would get the original problem. So since we can't break this up anymore, we are donezo. Circle the problem. Can't break this up anymore. So these are my final factors. Okay. Hope this video was helpful. Have fun doing the problems. If you guys have any questions, let me know.